All right, so we're doing the AtCoder Beginner Contest 182, which has just started. So let's see how it goes. Problem A, Twibbler. Let's see, it's like Twitter. We can follow at most 2 times how many are following us plus 100. We're following A and B are following us. Okay, so we just need to compute this simple arithmetic. The expression. Uh, 200, 300, 200. $20,100. This is 182 a.cc. Okay, that was right. That's good. B. I see. So we're given a list of numbers, and we want to find the number that divides the most of them, I guess. Okay, importantly, all the numbers are up to 1,000. If the numbers are bigger, this would be hard. You can actually just check all the numbers from 2 to 1,000. They're multiple, we can print any. Okay. I think this would be a harder problem with higher limits, but these limits are low enough that I don't think we need to be very clever at all. In the numbers. And you actually need to print out a number. Yeah. So we're just literally brute forcing it, right? Try all possible x's and take one of the ones, I guess the first one that produces the largest value. Sure. Two. No. 2. Okay, looks okay. Yeah, and literally just try all the x's. And we know it can only be 1,000 because we know the inputs can be almost 1,000. Okay, looks like that worked. C, 2, 3. So we're given a number where none of the digits are 0, and we want to make a multiple of 3 by deleting digits without changing the order. Well, that doesn't sound too bad. We actually only need to delete at most 2 digits. So the point is, you can tell if a number is a multiple of 3 by just adding up the digits. If there's 0, if the sum of the digits is 0 mod 3, then it's divisible by 3. None of the digits are 0, so all the digits are, sorry, there are numbers that are 0 mod 3. So anyway, we just need to delete like 1 or 2 We need to delete digits such that the sum becomes 0 mod 3, which sounds not that hard. Ah, an example where it's impossible. Okay, that's interesting. So yeah, I'm not actually 100% sure how to do this. You should read it as a string though, because we're deleting individual digits. Minimum number of digits. So we can just try deleting each digit and deleting each pair, I think. What are we supposed to print out? Minimum number of digits. Okay. Yeah, so I think if it's possible at all, it must be possible within 2 digits. Because, I mean, I don't know, there's only 2 different values, 1, 3. So we can only go through one wrong value before we get to the right value. Yes, I'm going to put it. we're only allowed to delete 2 digits. Actually, only allowed to delete 1 digit if n is at least 2. So I think this is right. Sort of brute forcing all possible options for 0, 1, and 2 to just delete. Okay, this seems correct. Looks like it's right. Okay, problem D. So we have this array of instructions, basically. Let's see. So it's sort of doing n squared instructions, and we need to find the maximum. So it would be easy to find the end, no n, but we don't want the end. We actually want the max. Okay, yeah, and so he's like you can stop or after where you are after few counts. You get the max. Oh, I see. Okay, I kind of see how to do this. Sort of simulate. So the idea is that we have this, and so So I think this is the final answer. Right, and so the point is that each of these is telling us to move basically some partial sum, And as we're doing that, the maximum distance that we get to is wherever we currently were plus this thing. It's just that. Start copying these into files. That produces 5, which is the right answer. Two, which is the right answer. 0, which is the right answer. Yeah, so I think this is probably right. And I don't know, I find this convincing. It was nice to write it down, so I got the exact sort of formulation that made it pretty simple. Yeah, so I guess the tricky thing here is this M array, which is just like among the steps that you're going to take as you go through PI, what is the maximum distance that you get to? And it looks like it was right, so that's nice. Problem E. Okay. So we have some grid. There are bulbs and blocks with some random square. I see. And number of squares illuminated. Only 1,500. So we can afford unsquared. Oh, I see. But we can't afford n times. Okay, I think I see how to do this. Yeah, so the idea is that we can't maybe afford to go from every bulb up, down, left, and right, because there's, you know, what is this, 500,000 bulbs. And up, down, left, and right could be 1,500 squares each, so that's like 6,000 squares that each bulb might illuminate. And so 1,500 times 5 times 10 to the 5, so that's 10 to the 8 from 1,000, and then 1.5 times 5, so it's basically like 10 to the 9. So it actually is pretty close. Maybe that is fun. No, I don't know. Maybe I should try that and then do the more complicated thing if that's something. Feels like that shouldn't work though. It's like too simple. R, C, N, N. N. that's it. I am expecting this to be too slow. And apparently wrong. This should be a vector bigger. Let's set my bounds check. And I did. It's a bit embarrassing. So one index. Okay. All right, I'll give this a try. TLE. Yeah, Makes sense, more or less. Okay, so the alternate idea is that for every square, we should find out if it's light or not. So how do we know if a square is light? Okay, it's too slow, so we'll follow that approach instead. Assume everything is on a distinct square. Should we set that? Yeah. Okay, 1 to represent bulb, 0 to represent block. set utility for pair, and that would be a pair of LL. Oh, those are the right answers. That's something. Yeah, so this is, I don't know, using some C++ magic, which we could, we could do ourselves, but it's nicer to use the feature of the language. So that it sort of does the binary search for us. Right, so this says, right, so we have this sorted list of objects in this position, and this says find the first object past our position in that sorted list. So if that thing is a light, then return true. And if there's an object to our left and it's a light, return true, and otherwise return false. So we just check both for our row and for our column if the first object, around us is a light. And if so, we lit up, and so that worked. Okay, cool. Maybe I should have started with that instead of doing the thing I thought was too slow. Okay, so we have a coin system, and I see each successive coin is a multiple, is like a whole number of the previous coin. I see. So this sounds sane. There's 50 different types of coins, and the coin value is up to 10 to the 15, which seems like an awful lot, I think our coin value is up to like 100 in real life, but all right. And the price might have been 10 to the 15. It's kind of a strange problem. Okay, so if the coins are 1, 5, and 10, and the price was 9, we need to figure out how many different amounts Lunlen might have paid. Lunlen is a dog. Sure, it seems irrelevant. So if he paid 9, he got nothing in change, so that's easy. If he pays 14, yeah, he got a 10 and 4 ones, and he got back a 5. All right, so the main requirement is you don't get back any coins that you gave, and you have to represent both of them minimally. Right, so if you give a 10 and 4 ones, you get back a 5, and that's fine. If you give just a 10, you get back a 1, which is fine. And if you give 9, you get back nothing, which is obviously fine. But if you give back anything else, for example, if you give back, say, 15, a 10 and a 5, then you get back a 5 and a 1, and the 5 repeats, so that's bad. That's a strange problem. In the first few examples, I was going to theorize that the answer is just n, but here we see that it's possible for the answer to be more than n. So yeah, certainly you can always pay the exact amount. That will always work. That's one answer. N is at most 50. I find numbers such that y and y minus x don't have any overlap in this weird, think of this as like a base system. So imagine that A was just the powers of 2. What would the answer be then? So that should be possible, just to like carry each digit essentially. That seems too easy. Let's go to try. So all we've done so far is just express x in our coin system. I think it's going to be useful. Good problem. DP is so simple. But I guess formulating the problem is somewhat difficult. All right, well, let's give it a try. This is right. This is such a weird problem because the actual solution, well, it doesn't look that simple, but it's very simple, DP. Just formulating it is pretty hard. And that is the solution. Okay. Yeah, so as I say, I think it's better to think of finding, instead of finding how much you paid, basically find what the change was. So C and C++ just have no digits. So if you decide to put something in digit I, then C++ have a 0 there. And the only way that that can happen is if you basically cause a carry in that digit. So the DP is just, the state is which digit you're looking at and whether or not you had a carry from the previous digit. The carry can only be up to 1 because you can only, I don't know, I mean, you can only put, you have to use the minimum number of coins to express the change and also to express X. So you can't possibly get like twice that many that cause a carry of 2. And so you only have, well, so what are your options given the state? So figure out what sort of digit you have right now, which is just whatever you had in X, and then also plus the carry digit. And this is how much causes a carry, right, to switch to the next type of coin. But this is how many AI coins you need to make an AI plus 1 coin. And this is how many AI coins you have right now. So if you have enough to sort of roll over to the next digit, then you aren't allowed to use any of these coins in Z. Because anything that you used would also appear in Z plus X, right? Like the point is that X plus your current Z already has like a 0 at this position. And so you can't put anything in Z at this position because that will also appear in Z plus X. So the only option is to put nothing in Z at this position, and we already have a carry for the next position. Similarly, if the current digit is 0, because we didn't have a carry and then the X had nothing here, then you can't put anything in Z at this position because it would also appear in X plus Z, right? There's nothing in X to cancel it out here. But we don't have a carry in that case. And then the final case is we have like a 1 in x at this position, and we need 2 coins to roll over. You could either not put not do anything in z here and just leave xi as is. So then this digit will appear in z plus x, but it won't appear in just z. Or you could put enough in z to make it carry over to the next place, in which case it will appear in z, but it won't appear in z plus x. And so in the first case, there's no carry. In the second case, there is a carry. And those are all the cases. So we just run dp in those states. And I guess the last thing to say is for the last type of coin, you can never use any of it in z because it's always going to appear in z plus x. So once you're looking at the last type of coin, there's no more decisions to make. Whatever you did for z so far is all you can do. Yeah. Right. So I mean, the point is that, like, just to make that last point more concrete, you can never use a 10 in the change here, because 10 is the highest coin, you must have also used a 10 in the payment. That's why once you're at the last digit, there's nothing left to do. So yeah, we just sort of basically run this DP, right? Read in the coin values, read in x, express x in terms of the coin values, and then run that DP. So that's the problem, and looks like the sensor was right, so that's actually all of the problems. So that is the contest. How am I doing in the standings? Number 64, sure. These contests are always a little bit strange because a lot of people solve all the problems. Maybe I could have gone a bit faster if I wasn't talking through them, although not as fast as this guy, I think. I guess he started on problem D. So anyway, that was the problem, or that was the contest.